Hey team, today we're looking over at an example of hypothesis testing with two large samples. So here we are, we have money spent eating out. A restaurant association says that two households in the United States headed by people under the age of 25 spend less on food away from home than do households headed by people ages 65 to 74. The mean amount spent by 30 households headed by people under the age of 25 is $1,876, and the standard deviation is 113. The mean amount spent by 30 households headed by people ages 65 to 74 is $1,878, with a standard deviation of 85. And so, at a level of significance at 5%, can you support the Restaurants Association's claim? Alright, so we have not just one sample, but we're looking at two samples, and they're independent, and they're large because they're just at 30, so less than 30 we'd have to use a different strategy for a small sample, but hey, we're looking at the large. So we got a few things we want to identify here. Well, A, we need to identify what they're actually claiming, what the null hypothesis is, and the alternative. B, we want to figure out the critical values, and identify the rejection region. C, we actually want to find the z-score of this problem and where they're at. D, we have to decide whether we reject or fail to reject the null. And E, interpret the most important thing, interpret the results. We can find numbers all day, but interpreting them and having meaning to it, that's what's important. Okay, well, let's go ahead and get started. What is the null and what is the alternative? So we have H naught, which would be, and so H naught always had the property of equality, and when we're looking at two items, we gotta determine which mean, which population mean is greater than or less than the other, or if they're equal together. Right now it looks like our first mean would be greater than or equal to than the other mean, the older group's mean. So mus of 1 would be represent the age of 25. Mus of 2 would represent the age of 65 to 74. And so, let's see here, the H of A, the alternative, we would have our mus of 1 be less than our mus of 2. And that's what they're claiming right here, because right here they said, hey, the Restaurant Association said that households in the United States headed by people under the age of 25 spend less on food. Okay, that's their claim, so that's important. We have to identify that as a claim. So, let's go ahead and make a little note here. Alright, so here's what they'd claim. Households in the U.S. headed by people under 25 spend less on food away from home than households headed by ages 65 to 74. So let's go ahead and write that. So households in the U.S. headed by people under 25 spend less on food away than households headed by ages 65 to 74. Okay, so in words, that's what they're claiming right here. The alternative is the claim. Okay, and that's good to know because when we're looking for language later on, we either use the word support or we use the word reject or fail to reject, and it looks like later on we'll have to use the word support because we can only support the alternative. Here we fail to reject or reject the null. Here we support or fail to support the alternative. So that's what they're claiming. That is part A. Okay, so moving on, part B looks like they're asking us to find the critical values. So let's take a look. We have the level of significance is at 5%. Alpha is at 5% right here. That's what they said. So with our alpha at 5%, we actually have to go to our table and figure out, hey, what's 5% convert to in our z-score? So let's pull up a table. And so here we have a z-score chart, and it looks like 5% would be about right in between these two numbers exactly. So our z-score would be negative 1.645 to go in between them. So our rejection zone would be at negative 1.645. So z0, hey, negative 1.645. And this is an important time to tell if it's a one-tail or a two-tail test, because otherwise this number might be wrong if it's a two-tail. So let's check. Our alternative is not an equal sign or a not equal to sign. Therefore, it is a one tail, and a nice shortcut of knowing if it's left or right. Look at which way your alternative is pointed. It's to the left. This is a one tail, left-tailed test. One left-tailed test. Alright, so I don't need to divide this number in half or anything like that. And what this represents is in our normal curve, here we'd have our z-scores, right? And of course 0, and in this case with two samples, we take the difference of them, our difference of our population means, to have it at 0, right? That'd be 0, and negative 1.65 would be somewhere over here. So that'd be our z0, and this is our rejection zone. Everything else, hey, would fail to reject. Alright, and of course we'd have our standard deviations, or the difference in our standard deviations being the bars 1 way, 2 way, 3 way, and so on. Alright, let's go on to part C. So part C, they're asking us to calculate the z-score of this problem. And so we have a lovely formula. I'll pull them both down. For a hypothesis test with 2 samples, here's what we have. We need the difference in our sample means subtracted by the difference in our population means divided by the difference of our standard deviation. Well, the difference in standard deviation can be calculated with this square root right down here, so this is actually what we're going to use. And so, plugging in the numbers from our example, they told us that the sample of people under 25 spent $1,876, and the people from ages 65 to 74 spent $1,878 in the restaurant. And we're going to assume, and so this would be in parentheses, and whenever you're doing these kind of problems at two-tailed, we always assume that the null hypothesis is true. And so if the null hypothesis isn't true, that means there would be no difference here. So if there's no difference between the two, this is going to be 0. And then underneath our standard deviation, or sample standard deviation, let's see, so the S, we'd have 113 was for our first group, so 113 squared, divided by 30 people, or 30 samples, 30 households I should say, added by, let's see, the next one we had 85 for our standard deviation in that sample, and we use the same number, 30 people. And so that is your formula. And when you calculate this, just take your time, make sure you use the order of operations. It ends up being like, what, negative 2 divided by almost 25. And so that's going to be about negative 0.08. And if this is negative 1.65, that means we landed about here, which means we're not in the rejection zone. So, going on to part D, which is, hey, decide whether to reject or fail to reject the null hypothesis. That means, part D, we fail to reject the null hypothesis. Okay, and what does that mean? Can we interpret this? Well, the best way to interpret it, and again, the most important part, what does all this mean? We got a number here, we had a chart here, what does it mean? Can we interpret it? Right here, we'd say, and so, yeah, there's not enough evidence at a 5% level of significance to support the claim that households in the U.S. headed by people under the age of 25 spend less on food away from home than households headed by people ages 65 to 74, okay? And that was the interpretation of this problem. Looks like we didn't get the rejection zone, and it looks like we couldn't support what they were saying. We tested it, and we can't support what they're saying. Alright, so there is an example of hypothesis testing with 2 large samples. Hope this helps.